All right, today we're jumping into a really cool new frontier, using AI to create perfectly realistic, perfectly annotated digital humans, pretty much on demand. The tech is called PoseDreamer, and you know what? It might just change how we train AI for good. Okay, just take a good look at these people. I mean, the lighting, the clothes, the dynamic poses, they look completely real, right? Well, they're not. Every single person you see here was generated by an AI. And the story of how that's even possible is, believe it or not, even more fascinating than the pictures themselves. So, let's get into it. If you want to teach an AI to understand how humans move and exist in 3D space, you need an absolute mountain of data. But getting that data, it's always been this huge, frustrating bottleneck. It's a problem that's held back everything from VR to robotics for years. For a long time, you were stuck with two pretty bad options. Option 1, use real data. Photos and videos of actual people. But that's crazy expensive, it's really hard to get enough of it, and trying to label it all in 3D by hand is just a total nightmare. So many errors. Option 2, you could render 3D humans, kind of like in a video game. That gives you perfect data labels, sure, but the images usually have that weird, uncanny synthetic look. Plus, you need a whole team of highly skilled digital artists. So yeah, both paths were seriously flawed. And this is exactly where PoseDreamer comes in. It's like a third path just opened up. Instead of trying to capture or render data, what if we could just generate it? I mean, what if an AI could act like an infinitely skilled, incredibly fast artist that just creates the exact data we need, whenever we need it? So, at its core, PoseDreamer is a pipeline. It uses the same kind of AI that powers all those tools we know, like Midjourney or Stable Diffusion. But here's the key difference. Instead of just making cool pictures from text prompts, it's specifically designed to generate millions of photorealistic images of people, where every single pixel comes with a perfect, corresponding 3D model. It's the whole package. And it all works in a really clever three-step process. First, it just gathers thousands of 3D poses. You can think of these like digital skeletons or blueprints for the human body. It gets these from existing motion capture data and also from analyzing real photos. Then, step 2, another AI looks at each blueprint and writes a little description, something like a person running on a beach at sunset. And finally, the main AI artist takes that 3D blueprint and the text caption and generates a brand new, totally photorealistic image that perfectly matches both.
But there's a catch. Having a creative AI artist is awesome, but sometimes they can be a little, let's say, sloppy. It might not follow that 3D blueprint with the pixel-perfect precision you need. So the researchers had to figure out a way to teach this artist to be incredibly precise.
And really, this is the most important question of all. I mean, if the final image doesn't perfectly match the 3D pose you gave it, then all that data is basically useless. So how do you force a super creative generative AI to, stay within the lines and stick perfectly to that initial blueprint? Well, the answer is this really clever technique called direct preference optimization, or DPO. The best way to think about it is like you're an art teacher for the AI. For a single 3D pose, the AI generates 2 different image options. Then, the system automatically figures out which of those 2 pictures is a more accurate match to the 3D blueprint. And then it goes back to the AI and says, see this? The one on the right is better, the one on the left is worse. Learn to make more images that look like the better one. You do this millions of times, and the AI slowly learns to prioritize precision over just pure creative freedom.
And you can really see the difference it makes. On the left, you've got the baseline model, and it often makes little mistakes. A leg is just a bit off, an arm is at the wrong angle. But look at the right. The DPO-aligned model is so much more consistent. It shows what the paper calls greater adherence to those 3D parameters. It basically learns to be a master of precision.
And we're not talking about a small improvement here. This DPO training process led to a staggering 42.1% reduction in the pose error rate. That is a massive leap in accuracy. It completely transforms the AI from like a talented amateur into a true professional.
Okay. So now we have a precise AI artist. But even a master makes mistakes sometimes. To make sure the final data set is absolutely pristine and actually useful, the researchers built what they call the Quality Gauntlet.
The thinking here is pretty simple. Garbage in, garbage out, right? If you want to train the next generation of AI that can understand humans, you just can't have a single flawed example in your training data. So every single image that PoseDreamer creates has to go through this intense, automated 3-stage inspection. So here's how this gauntlet works. First up, a simple crowd check.
any picture with more than 5 people in it gets tossed out immediately, just to avoid any confusion about which person is supposed to match the blueprint. Second, and this is the most important one, is the pose alignment check. It uses a metric called Object Key Point Similarity, or OKS for short, which is basically just a mathematical score for how well the joints in the image, like the wrists, knees, and shoulders, line up with the 3D blueprint. If that score is too low, the image is rejected, gone. And finally, there's a head pose check to make sure the head's orientation in 3D space is also correct.
And this slide gives you a perfect visual of what that OKS check is looking for. Over on the left, you've got a sample that failed. You can see how the arm pose in the picture doesn't quite match up with that colorful blueprint overlay. That gets a low OKS score. But on the right, you have a sample that passed. The alignment is almost perfect. It gets a high OKS score, and it gets to go into the final dataset.
This chart, a histogram, really drives home just how selective this whole process is. It shows the OKS scores for thousands of images that the AI generated. And you can see a lot of them are just okay, kind of falling there on the middle. But PoseDreamer's filtering system is super strict. It sets a really high bar and only accepts the images in that top tier, way over on the far right of the chart. Everything else gets thrown away. It's all about ensuring that ultimate quality.
So, after all of this, the generation, the precision training with DPO, and that absolutely ruthless filtering, what's the final result? What does this new era of AI-generated data actually look like in the end? The result is a brand new dataset with over 500,000 images. And every single one is photorealistic, they're super diverse, and they come with those perfect 3D annotations. It's the kind of resource that was basically impossible to create before now, and it's letting us train AI models that are more effective than ever. And when we talk about photorealism, the numbers here are really something else. This chart compares PoseDreamer to other big synthetic datasets using a metric called FID, and all you need to know is that a lower score is better. As you can see, it's not even close. PoseDreamer's images are just dramatically more realistic, which is absolutely critical if you're training AIs that need to work in the real world. But this is probably the most powerful conclusion from the entire research paper. When training a new AI, mixing PoseDreamer's generated data with other datasets actually led to better performance than mixing real-world data. Just think about that. It suggests that this new, perfectly clean AI-generated data might not just be a substitute for real data. In some cases, it might actually be better. And that leaves us with a pretty provocative final thought. For decades, progress in AI has been all about the data. Who has the most? Who has the best? But if AI can now generate its own perfect training data, customized for any task, pretty much on demand, what does that mean for the future? What will we even need real data for? It's a huge shift, and we're really only just beginning to see what it all means.